What if you could run a language model 6 times faster at a million token context and actually get better results? That's what Moonshot AI claims with Kimi Linear. Let's break it down. Standard transformer attention has a dirty secret. It scales quadratically with sequence length. Double the context, quadruple the compute. Was the KV cache, the memory that stores past tokens during generation, grows without bound. For agentic AI doing long multi-step tasks, this is a wall. Linear attention fixes the complexity problem by replacing the softmax with a recurrent state. But historically, it paid for that efficiency with worse quality until now. So essentially, it was proven that we can rewrite linear attention as a recurrent neural network. So the idea of recurrence, having a hidden state and upgrading that state is there, but actually speaking, the performance is not at par with the softmax attention. So Kimi Linear is a hybrid architecture. Most layers use a new module called Kimi Delta Attention or KDA, which builds on the gated delta net. The key upgrade is instead of a single scalar forget gate per attention head, KDA uses a channel-wise gate. Each feature dimension gets its own independent forgetting rate. So why does that matter? Think of the recurrent state as a fixed size memory bank. Coarse gating wastes slots by forgetting everything at the same rate. Fine-grained gating lets the model selectively hold on to what matters and discard what doesn't. Much closer to how you'd actually want a memory to behave. Every fourth layer, KDA is replaced with the standard full attention layer, no positional encoding. This hybrid 3:1 ratio preserves global recall where linear attention is weakest while keeping the KV cache 75% smaller overall. So there is a subtle hardware insight here too. The natural generalization of this architecture leads to something called DPLR or diagonal plus low rank transition matrices which are expressive but slow. Kimi Linear constrains the two free vectors in DPLR to both equal the key vector k. That single constraint eliminates two secondary chunking steps and three matrix multiplications per block, roughly doubling kernel speed versus the general formulation. So trained on the same 1.4 trillion tokens as the baselines, Kimi Linear beats full attention on short context benchmarks, long context retrieval, and notably reinforcement learning scaling, where it pulls ahead of full attention and keeps widening the gap as training progresses. So that is the key idea. Number one, this is a new architecture. Number two, we are exploiting the linear attention to make transformers more efficient and more accessible to the general public, and it is also working really well with the current hardware systems.